Hi, my name is Ava Hill, and I'm going to be presenting on Dr. Alexa Canady, the first ever female African American neurosurgeon. Dr. Alexa Canady was born on November 7th, 1950. She grew up in Lansing, Michigan with her parents and her brother. Early on, Canady's parents taught her about the importance of hard work and learning, which was an essential part of her success. Dr. Canady graduated from Lansing High School in 1967 and majored in zoology at the University of Michigan. It was during her undergraduate studies that she attended a summer program in genetics for minority students and fell in love with medicine. She then went on to attend the College of Medicine at the University of Michigan, where she graduated with honors. Dr. Canady completed an internship at Yale and then trained as a resident in neurosurgery here at the University of Minnesota. In 1981, she became the first ever female African American neurosurgeon. Though this feat didn't come without its challenges. Neurosurgery was a career path that some of her advisors discouraged her from pursuing, and she had difficulties obtaining an internship. Her hardest obstacles were convincing the neurosurgery chairman that she was not a risk to drop out or be fired, and convincing herself that someone would give her the chance to work as a neurosurgeon. After finishing her residency, Dr. Canady decided to specialize as a pediatric neurosurgeon. One of her hobbies included playing video games with her young patients in order to have fun and build her relationships with them. Dr. Canady worked incredibly hard and achieved her goals despite the doubt coming from herself and others. I aspire to be as resilient and driven as Dr. Canady, and although I won't have to endure much of what she had to endure, being the first Black woman in her position, I will attempt to mimic her resiliency throughout my educational and occupational journeys, and I hope to be as passionate about what I decide to pursue as she was with neurosurgery. During her career, Dr. Canady engaged in research to make advances in neurosurgical techniques with a focus on the treatment of hydrocephalus, an abnormal accumulation of fluid inside the brain. One of her early articles was written on the effects of hydrocephalus in hamsters, where hamsters were injected with a hydrocephalus-inducing agent and then decapitated to observe the effects on their brains. Her research led to the invention of a programmable anti-siphon shunt, a device that treats hydrocephalus, for which she shares a US patent with two other neurosurgeons. The most recent article that Dr. Canady helped write is titled Immune Reactions Associated with Silicone-Based Ventriculo-Peritoneal Shunt Malfunctions in Children. A ventriculo-peritoneal shunt is a medical device that relieves pressure on the brain caused by fluid accumulation. In this study, they explored whether or not the proteins attaching themselves to the shunt cause an immune response and whether this response leads to shunt malfunctions. To carry out this analysis, they collected pieces of shunt tubing from revision surgeries and used guanidine wash, vortexing, centrifuging, and BCA protein assay to determine the amount of proteins attached to them. They used antipolymer antibody assay to detect any antibodies, and the ANOVA test was used to give a statistical comparison between result groups. From this study, they found that the failed shunts harbored significant amounts of attached proteins and antibody responses to these proteins, which suggests that an immune response to silicone-bound proteins most likely plays a role in shunt malfunctions. The next steps for this research are to figure out why proteins are attaching themselves to the shunts and to either choose or design a biomaterial that will prevent protein binding and be easier for the body to accept. Here are my references. Thank you for watching.